Okay, hello again. It's 5:26. Let's pretend I said this 30 seconds earlier. Okay, hello, 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 hello. You guys should probably go sit down. Cool, so we've talked about functions, and functions are cool, and hopefully they're a little bit less confusing than they were yesterday. But let's talk about variables again for a bit, because I know we started out and we talked about variables pretty much on day one, but there's a lot more depth to them than we might realize. So first of all, let's think about variables and values as being separate things. So when I say a value, I mean a value could be a number. So a value could be a number, like a value could be the number 5, or it could be the number 3.1415926535, and so on, to make pi. Those are both different values. A value could be a letter. We could have the letter A, or the letter P, any sort of letter. A value could be a word. It could be like hello, or it could be my name, Andrew. It could be a series of words, you know, hi there, how are you? A value is just this concept of a thing, a value. It's about as well as I can explain it. Conceptually, we have a value, and then a variable, conversely, is something that holds a value. So when we say something like int I equals 5, we're saying, hey, 5 is the value, and let's just use I as the box that we put this value in for now. And so, in terms of how variables actually work, variables in our programs are stored in a thing that we refer to as memory. So you might have heard of memory in your computer, like you've got RAM in your computer, you've got a hard drive and various things like that. So when we talk about memory in our programs, it's sort of the computer manages all of that sort of for us, and it gives us some stuff on the RAM in the computer that we're working on. But we can refer to it just as memory. And so if you think about how variables are like boxes, it's like we have this box that we can put the number 5 in, or we can put any value we want in. The memory in our program is just like a whole bunch of boxes that are all lined up in some specific order. I might try and I'll switch to the document camera. Is that going to work? Yeah. So, like I've said before, in our program we might say something like int I equals 5. Is that readable? People down the back? Yes, I got one thumbs up. That'll hopefully do it. So when I say int I equals 5, what I actually mean by that is, hey, in my program, give me this box that'll fit a number in it, give it the name I, which is a pretty bad name, and put the number 5 in there. So I might say something like int age equals 92. Someone's age might be 92. So I could have another box that's called age and has the number 92 in it. And so in my program, every time I make a variable, I'm just getting another box that I can put things in. I can also change the things that are in my variables. So I might go int I equals 5. Well, let's change it. Let's say that I now equals 15. And so what will happen in my program is the box that the 5 was stored in, the box that's the variable I that currently holds the value 5, will now have the value 15. And so it's important to sort of get the distinction between the variable itself, which is just this box that we can put things in, and then the value that we put inside the box. So I could change this to be whatever I wanted, within reason. I could say I equals 0, and then that would change the contents of this box to be the number 0. This book's a lot better on a whiteboard, as you can see, but that's now the digit 0. And so the memory of my program is just a series of boxes, and whenever I make a new variable, it'll just put it in the next available box. So I'll draw them up this way. You see all of those? Yeah, cool. So this might be the memory of my program, and I might start out int main, squiggle, squiggle, squiggle. And so I might start out in my main function by saying int speed equals 100. And so what's going to happen in my program or on the computer, it's going to go, the next free box is this one here. And it's going to say, okay, this one here is now called speed, and it contains the number 100. And so then when I make another variable, maybe I'll say like int license type. And so if you remember from the license program we had, you could get a different type of driver's license. And so I might say license type equals the get license type function we wrote. And so in this case, I'm calling the get license type function. I've shortened the name because I'm bad at writing big things on paper. And so this is going to make me a box here. Or rather, it's going to take the next free box, which is this one here, and it's going to call it license type. This box is a license type. Then it's going to go after this function, the get license type function, somewhere else. And let's put it on a new piece of paper. So over here I've got my get license type function, and so this might say a variable called type, which is going to store the license type. Then we're going to do a scanf, get me a number, whoops, put it into the variable type. And so if the user types in, I know this had it printed out what license type do you have, 0 is learner, 1 is whatever. So the user might go, I've got a learner's license, and type in 0. Then this box will have the number 0 in it. And then the bottom of my function, I might say return type. So my close one will go down there. And so you can see inside my get license type function, it's got its own series of boxes to put things in, its own kind of fresh piece of memory. And just like in the main function, it'll start from the first free one and then put things in as we go through. So in this case, we gave a name to the first free variable slot, the first free piece of memory. We called it type. We scanned in, the user typed in 0. We're going to return 0. So now because this function's finished, it no longer exists. The memory that was in there is gone. It's still on the computer, but it's no longer being used by that function. And then we jump back into our main function. And if you remember, the get license type function returned the type. And so I've called get license type. It's going to return the type, which was the number 0. So it's going to put the number 0 in the box in this one here. So does that make sense so far? We have this concept of values, which are the actual numbers, or the, in case of things we haven't got in our programs yet, like words and sentences and that kind of thing. And then we have the variables, which are the things that actually store those values. Okay, and so as we go through our program, as we make a new variable, or as our program encounters a new variable that we've made, it'll just go to the next free slot and put whatever we scan in, or whatever we type in, or whatever we declare it to be into that box. Maybe I'll make a function called go faster, which makes your speed be faster, because just in case you weren't speeding enough as it is. So I'm going to say, sorry, not get. Got a function called go faster, and I'll give it the current speed but I need to actually do something with the speed if I want it to be going faster. So I'm going to take my current speed, give it to this function called go faster, and then it'll give me back the faster speed. So in this case, I'm going to write speed equals go faster speed. So ignore that line. And so what's going to happen here? It's going to go, I've already got a box for the variable speed. So I'm going to go back up to this one here. And I'm going to change the value to whatever this function gives me. And so then if we go to the go faster function, I might rewrite these on the computer later on so you can see them more neatly. But my go faster function will take in the current speed, and let's say return the current speed plus 20. Cool, so the program's gonna go to my go faster function. It's gonna go, you've given me the current speed was 100, and I'm gonna return back to you 100 plus 20, so 120. So now, back in our main function, we've just called the go faster function. It's told us, okay, I'm going to give you back 120. So the program's going to update the speed variable, now has the value 120. Okay. Hopefully that makes sense so far. So conceptually, the values and the variables are different, distinct things, and we can change what's inside our variables, so we can update the values inside them. And the memory inside our program is a series of boxes that are all lined up in order. I'm going to go to the next slide, which you can't see. But the next slide is just saying, well, where are the variables stored in our program? And the answer is that the variables, or the locations in memory, have an address, which is the location of where they are. So we could think about it in terms of the lecture theatre. Each of you is in a seat. You're in a specific seat. So I might number them. I could start with you, could be in seat 0, then seat 1, seat 2, seat 3, seat 4, seat 5. Then I'll go 6, 7, 8, 9. I'm not going to count all of them because it'd be a lot of seats, but that'd be, I don't know, maybe seat 20 on the end, and then maybe seat like 21 across there. All the way through to is there a sign saying how many people there are? All the way through to the roughly 500 seats in this room. And so, just like how each seat in the room is in a different place, and we could give it like, refer to it as seat number 0, or, hang on, those have rows and columns on them, don't they? Because this is used for shows. Does it have a row, column, or a number or something on it? A. Yeah, A6, perfect. Perfect for my example. So that seat there has it's the seat number A6, or A06. So you could refer to it as a seat that's in position A6, I guess, because conveniently they've numbered the lecture theatre for us. And so, similarly to how every seat in this room, we could just say, that's the first one, that's the next one, that's the next one. Our memory is done like that as well. And so we might say that this is a memory address. I'm going to start at 100, because address 0 is special for reasons we'll get into in the future. So I'm going to say address or box number. And that's this column here. So I'll say that this one here is at address 100. This is at address 101, 102, 103, 104, 105. And of course in my program there'll be a lot more than 100 or a lot more than 5 addresses, but every box that we have, every variable that we have in our program has some location in memory. It's at some address somewhere. Like there is one spot in our program's memory for our variable index or for our variable speed. Okay, and now you can see the slide, and you can see that I wasn't lying to you. It did actually say that. So locations in memory, the variables in memory, have what we call an address. And conveniently in C, we can see what address something is in. In C, we can see addresses. Ha ha ha, no pun intended. So we can actually find the address of where something is. And the way we do this, the syntax for doing this, is with the AND, or the ampersand symbol, Shift 7 on a keyboard. And you've actually seen this in scanf before. When we say scanf %d ampersand num, we're saying hey scanf, put the thing into this variable called num, right? But what we're actually doing there is we're saying, hey scanf, here's where num is in memory. And then scanf goes, num's over here. I'm going to put the value that I scan in into that place where num is. So let's have a play around with this. I'll call this one, oh no, there's two things called week 3. And they're both the same place. I'll just pick this one. Okay. I'll call this one addresses. So, hash includes I'm doing this first so I don't forget to do it later on. Cool, and so let's do some stuff we've already done before. So int number, and let's printf, type in a number, and we'll scanf, put it into the location of number, and then we'll print out you typed. Cool, so this program, we've made an integer called num. So what we've actually done is we've said, hey, get the next free slot in our program's memory, and we're going to refer to that as num from now on. So then we're going to say to the user, okay, type in a number, we're going to scan in a number, we're going to tell scanf to put it into num, or we're going to say, hey, scanf, here's where num is, this is where you can put it into, and then print out you typed the number. So, all going to plan. A brief tangent. So I've shown you tab complete before. So when you're typing in the terminal, you can hit the tab key, like the one above caps lock. And it'll complete if it can. So in this case, I've typed in add. That could be add numbers or it could be addresses. So I'm going to go addr for addresses and hit tab. But you'll notice that I delete the .c off the end. That's because when I say dcc-o addresses.c or whatever it is, I'm saying, hey, when you compile my program, put the program you make into this file called addresses.c. And you'll find, I'll save it back up. When we try and do this in DCC, hopefully, DCC is going to say, hopefully, yeah, DCC, I'm not going to override addresses.c with machine code because I'm a nice compiler. I'm going to warn you about that. But if you're doing something like GCC, if you're doing it on home without using DCC, so in a compiler at home, for example, if I type in gcc-o addresses.c, I'm saying compile the code from the file addresses.c and save the compiled program into the file addresses.c. And so I'll do this. And now if I open my file addresses.c, it's still red and it's saying bad things are happening. I'm just going to go, yeah, okay. Ensure you're not opening a binary file. Well, I am. It's intentional. Is it not going to let me open a binary file? Okay. Let's try something else then. So I think I've shown you the cat function before in the terminal. I think last time I did this and I catted a binary, it crashed. So let's hope it doesn't. But so I can cat like license.c, and that'll print out the contents of the file called license.c. We can see it's all the way up there. And so I could cat, the source code I've made. I've called it backup addresses just to be safe. And then when I did my gcc-o and I saved it into addresses.c, now if I cat addresses.c, my source code has become this kind of messy thing that isn't actually my source code at all. So be very careful when you're running your compiler that you say -o and then not your source code file name. So otherwise your beautiful source code will become this sort of mess. But thankfully, I saved it back up. You should always have backups on your computer. I'll rename this one back to addresses.c. Cool. So be very careful that you don't type -o and then your C file name. Okay. Put it into addresses, call it addresses.c. So if you remember, I'm typing in a number. I'll type in 10, and you typed in 10. Cool. So this is hopefully familiar to us, but let's look at where it's putting it. So I can print out the number num, right? I've already got that down here. But what if I print out &num? What if I print out the address where num is? What do you think it's going to do? So hopefully what it's going to do is it's going to give us the address of num. The question is, what does that address look like? And so I've just got to print the address of num is this, and then &num, so whereabouts num is located in memory. So I'll compile this again. So it's giving me a warning because it's telling me I'm trying to print it out as a number, but instead of being a variable that's a number, it's the address of a variable that's a number. So it's upsetted me. Here we go. So I typed in 100. It says you've typed in 100, and the address of the variable num is -2,614,256. That's a weird place to put it, don't you think? In like a negative location. What will I say first? So you might remember we looked at hexadecimal numbers in the lab this week, and we looked at actually writing them like on paper and stuff last week. So we can print them out with %d we print out an integer number, like a normal number in base 10 or decimal. But we can use %x to print it out in hexadecimal. And so I'll do that with this for a start. So I'm going to type in the number 100. So it says you typed in 100, and then I printed it out over here with %x, so in hexadecimal, and that gave me 64 in hexadecimal. I believe, was it a hash symbol, tutors, to print out the x? Maybe. Oops. There we go, cool. So you can, when you do the printf, you can put a hash inside, and it'll print out the 0x in front of the hexadecimal number, because that's how we distinguish that it's one of those. And you'll see that in the lab this week if you want to look at it more. So we can see we typed in 100, which in hexadecimal is the number 0x64. And let's print out the address of that in hexadecimal as well, and see what that looks like. So recompile, run, 100. Okay, so I typed in 100. 100 is 100 in decimal. It's 0x64 in hexadecimal. In decimal, it's this -2 million number. And in hexadecimal, that's 0x FF D3 D5 D0. So that's a bit of a weird number. As you do more programming and play around with things like addresses and where variables are in memory, you'll start to recognize that the addresses start with 0xFF. So just for fun, let's make another number. And I'll say that another number is number times 2 to save having to scan something in twice. Cool, so the address of another num as an integer and as hexadecimal. Cool. Cool. So I've just made myself another variable. It's also an integer. I've made it be 2 times what num is, just to save having to scan something else in. And then I'm printing out both the address of num and the address of another num. So let's see what this looks like. I have 100 again. There we go. So we can see I typed in 100, which is 0x64 in hex. The location, wasn't that at -2 million before? So the address of num is now this number, and in hexadecimal it's this number here. The address of another num is this slightly different number, and its address in hexadecimal is this slightly different but very similar number. So I'll leave that as something for you to think about and ponder about. We have so we'll look at this more in the future, but I just wanted to show you when we have variables, we have the distinction between the variable and the value that's inside the variable, and all variables have a location, and we can look at that location for now. Okay. 3 more minutes, and it'll be over. I want to show you one thing really quick that's in one of the lab activities, the Confusing Code 1 this week. I'll do it here. So I can say num plus equals 5. And this confusing line of syntax is equivalent to saying the variable num equals itself plus 5. And I'll run that quickly and show you. So I scanned in the number 100. I said num equals num plus 5, so num is going to be 100 plus 5, which is 105. And then it said you typed 105. And the same, different syntax to do the same thing is saying num plus equals 5. So it's still going to say I typed in 105. So the syntax is just saying take the number num and add 5 to it, and then set it to be itself plus 5. Okay, so one thing to just think about really quickly that I've sort of touched on already. Thinking about when we run our programs, what actually happens, like how does it run? And so I'll jump back to the document camera. So you saw in my beautiful main function here on paper before that I have my main function. And so when I run my program, it starts out at the start of my main function, because whenever you have a C program, the first thing it does is the first line in that main function. And so we went through here and we showed int speed equals 100, and so we put the value 100 into that box called speed. Then when it's finished with the first line, it moves on to the second line, which might seem kind of straightforward. Does the thing, does the next thing, does the next thing. So then it goes to this int license type one, equals get license type. Okay, be quiet, please. 1 more minute. You can do 1 more minute. So when we have this line of code, we say license type equals get license type. Our program's going to jump to whereabouts our get license type function is, and then it's going to run through this line by line as well. I'll put it sort of over there. So it goes into the get license type, which says make me an integer called type, so call this next free box type. Scan something into type, return type. Then when it's finished with this function, it's going to go, I've got to the last line, I got to the return. Then it's going to go back to where it was up to in the main function.